The next area we're going to look at in this outcome is the third one here, exploring different representations of fractions. So in this part of the unit, students are going to look at three different models for representing fractions: the set model, area model, and linear model. They're going to explore different strategies and they're going to compare the three different models. In our grade 5 curriculum, we're still working in this learning outcome where students interpret improper fractions. And so where we're going to be focusing here is this first skill and procedure on relating fractions, so improper and mixed numbers, to their position on a number line. We established a little bit of that in the last lesson. We're going to continue to build on that. We're also going to do a lot of modeling of fractions here, including mixed and improper fractions, and we're going to use model using quantities, lengths, and areas. That's going to be the big focus of this piece of the unit. And then we're also going to look a little bit at expressing improper fractions and mixed numbers symbolically. That's using the actual numbers symbolic representation. So we're continuing to interpret those improper fractions. We start off with this slide deck from Mathology that tells the story of Hannah and her chickens. And there's three different activities in here. Each of these activities could be done on a separate day because they focus on each of the three models. So we start here with the set model. We're going to do lots of work representing that. Then we move into the area model and the linear model of representing fractions. So let's start with activity A, the set model. So Hannah, our friend, has some chickens, and her chickens have just laid some eggs, and she's gathered the different eggs together. She wants to make a set model to represent the different kinds of eggs. This activity works best if you give students the manipulatives. We want to make sure that they have a concrete understanding of how fractions work. We want to make sure that they understand the set model here before we start building them into more abstract and symbolic representations. So what I've done is use some color counters to represent the different eggs. There's digital counters linked within these slide decks and within Mathology. You could give them Unifix cubes, any sort of counters so that they could create a set model. And so we're going to show this problem, and we're going to say, using your manipulatives, represent the eggs and the fractions that you see. So what I'm going to do here is my two red chips are going to represent those two orangey red ones, red eggs. I have two blue. I have two green. I have two like light orange, which I'm going to represent as yellow, and then one white egg. So how many eggs are there all together? We want to see that there are 2, 4, 6, 8, 10 eggs all together. And so how do we represent fractions using this set? Well, let's make a fraction for the number of red eggs. Is that just 2/10? And of course, our students should know how to reduce fractions from grade 4. So can we divide both of these in half? They're both divisible by 2. So does this give us 1/5? Does that mean that 1/5 of the eggs are red? What if we were to make a fraction of the yellow? 3/10 of the eggs are yellow. Can we reduce that? Students can work on that skill to make sure they can do that. How many are white? There's 1/10 are white. Could we write these as decimals as well? Is this just 0.2, 0.3, 0.1, and so on? So we want to name all the fractions that we see, and we want to show what each fraction represents. Make sure that students can do this using concrete manipulatives. If you really want to get into the weeds, you can see that some of these fractions have dots, so specks. So you could do like speckled fractions against the whole and stuff too. This is some ratio work as well, but spend some time, probably a good chunk of the class, working on this task. You could then give these practice questions. These are the printable practice in Mathology. After that, set model work to solidify students' understanding. This first question has to do with that exactly. It's a knowledge and understanding question, so this is a mild entry-level, surface-level question. This second one is still using a set model, but it does add that communication piece in it, so it's a little bit more it's a little bit more spicy, I guess, but it is asking for students to explain and identify the whole. So students could do this independently or in small groups, but this is going to solidify this set model work. So that whole set model could be one class, warm up, manipulatives model practice with Hannah's eggs, and then these two questions to consolidate. Activity B in the slide deck focuses on the area model to represent fractions. And so there are two slides for this activity, and there's this printable that is helpful to give to every student. It is very helpful to have it cut out so that students are able to fold it and manipulate it. So what this activity is saying is that this is the space where Hannah's chickens live, and this there's an indoor area here called the coop, and there's straw and wood shavings in here, straw on one side, wood on the other. And then we have an outdoor area over here, which is called the run. And this floor plan shows the whole area. So we want to ask students, what is the whole? And really, we want them to understand this is the whole. Yeah, so establish that this is a rectangle that represents the whole chicken coop. So there's a few questions here. What fraction of the area is outdoors? What fraction of the whole area is indoors? What fraction is covered in straw? What fraction is covered in wood shavings? And so what we want students to be able to do is fold and come up with some reasoning and thinking. This activity is best done in small groups, groups of 2 or 3, because the idea is to share and collaborate and discuss and debate and reason. And the point is not to really get too far into the weeds about an exact answer. It's not about the exactness, it's about the thinking and the reasoning. So this is a very open-ended task. For example, if I fold this outdoor area, I mean, I can see right away, I know that it's not half. But it's also not a third. It's like more than a third. It's less than a half. So like, what fraction is it? Like, how can I use folding strategies in order to figure out what fraction this is? I wonder if I could fold that in half again. And if that, like, are these two pieces equal? Like, is half of the outdoor area the same as what's left over when we cut it in half? And so does that mean that there are potentially, I don't know, let's see, 1, 2, 3, 4, 5 half outdoor areas? So the outdoor area is what fraction of the whole? We can do the same with the straw, right? Students can also recognize that, just because the area is cut in half diagonal, it is the same area as if we were to cut this in half vertically as well, or horizontally. So I would ask students to do that, to figure out all the fractions in as many ways as possible, with the most flexible answers possible, and represent all of their fractions on a piece of paper or a whiteboard, be able to justify and reason and explain their answers. This activity could lend itself to a really rich discussion where students agree and disagree and change their minds. And this is a great activity to show the area model. We also want to compare the area model to the set model that we did before with the counters. What's the same? What's different? What are the advantages and disadvantages of each, so that they can start building these three different models in their heads. As a consolidation for this task, at the end of the class, we could give question 6 from the practice sheet to students, where they have to take this rectangle and partition the main floor to show what it would look like. So are the students understanding the concept of using the area model, and are they able to cut this up into the fractions? So I would just give them this at the end of the class for activity B, area model. Activity C is focused on learning and representing the linear model for representing fractions. So here, Hannah races her chickens from the coop to the fence. Sometimes they get distracted and they don't make it all the way to the end. They only make it a fraction of the distance to the fence. So here are the fractions of the whole distance that the chickens ran. We have 5 different chickens here at their distance. And then we have some interpretation questions. So for the linear model, we want to teach students to be able to represent these fractions and compare and order them on a number number line. They did some of this work in grade 4, so this should be fairly familiar. An open number line is best. There's printable ones on the mathology.ca site, or they can use whiteboards or chart paper, whatever works. When we do an open number line, first of all, do we have anything greater than 1? Not here. So 0 and 1 is what our number line is going to represent. It's also beneficial to build in benchmarks. So we know 0, we know 1. Where's half? Like, would half be a good benchmark? Maybe. So let's draw half. We could even put quarters in there. Why not? Let's try it. Here's our quarters. They learned in grade 4 how to partition a number line in this way. This is 1/4 and 3/4 here. So now we have some benchmarks to work off of to be able to think about where to plot these different numbers. Because this is a little bit of a review from grade 4, it would be perfectly fine to let the kids go in groups of 2 or 3 to solve this problem together. It's not about correctness, it's about closeness. The purpose here is the thinking, and so it's not about you're right or you're wrong, it's about how do you know? Right? How can you justify what you're thinking? So just so that you have the experience of going through it, let's do this together. So the first one that stands out to me that is easy to plot is Bernice. Bernice ran half of the way, and we already have a benchmark of half. So I'm going to put Bernice as 1/2. Okay, what else? Willie stands out as 6/10. I know that 5/10 is half, and so 6/10 is going to be a little bit more than half. We want to see if students have that ishness, right? That little bit more. So I don't know. I'm going to say maybe about there is 6/10, and that's Willie. We'll label it with Willie. Okay, 4/5, 5s. Okay, so now these are kind of tricky because they're very close to the whole. Like 5/6, 4/5, and 8/9. Those are all going to be, I know, somewhere up here, but I'm not sure which order. So what are some things that I can think about? Well, I know if I'm comparing, if I compare like fifths, if I just think of a chocolate bar, 1, 2, 3, 4, 5 fifths, and I take the same size chocolate bar and I cut it into sixths. There's 6 now. Oh, that's terrible. 6 of them. And then I take the same size chocolate bar and I cut it into ninths. This is going to be hard for me. Ninths. 1, 2, anyways. 3, 4, 5, 6, 7, 8, 9. That's good enough. What I know is that the smaller the denominator, like this is sixths, this is this is fifths, this is sixths, this is ninths. The smaller the denominator, the smaller the piece, which means that for example, the 8/9 is going to be closer to 1 because that extra ninth is really, really small. So I'm going to say that 8/9 is here. Right? Whereas 4/5, that last fifth to get up to the 1 whole is going to be a bigger chunk than the ninth, right? So I think that 4/5 is 4/5 greater than 3/4. Yeah, because I think if I think about like 3/4, if I cut this into quarters, right? Quarter is going to be here, fifth is going to be here. So I think this is going to be 4/5, which is Harriet, which means Howie is going to be just a little bit bigger. 5, 6. This is tricky. This is like hard thinking, right? And so again, it's not about perfection and it's not about exactness. It's about the reasoning and the thinking. The conversation that comes from this, not only in the small groups, but when you come back as a class to share your thinking, is the richest part of this task. I would take the whole class to do this because there's so many interesting things that you could talk about. So the question is, who ran the farthest and why do you think so? I think it was Mildred because it's 8/9. And use benchmarks to find all the fractions, and we could use actual number lines to actually check it, cross-reference it. We can do all that work. But this is a really rich task. Give kids lots of time and space to be able to think and talk and listen to others thinking around this one. Back to our printable practice pages, I think I would give question 3 to consolidate the learning from this one. There could be other options, but this one I think is conducive. We have two people who were drinking juice. Who drank the most juice? And so I would ask students to represent the two juices on an open number line, compare and order them, and then answer the question who drank more juice and justify their thinking. This would be a great exit ticket and consolidation of the learning. They could do this in groups or individually, however you feel, but this would be a great one to wrap up that lesson. Now that students understand all three models, the set model, the area model, and the linear model, the rest of these practice questions are going to help them apply them to different contexts. So question 4, for example, is a knowledge and understanding question. I would label this a mild question. It's fairly surface level, but we could cut this one out and allow students to choose to answer this one. If they want to get a little bit spicier, question 5 is about chicken feed, and so this one is a thinking one. And they have to really think and create in this one. I would label this one, I would say this is a spicy, actually, medium to spicy, but for sure not surface. And then I think I got all of them there. And then there is also an exit ticket. Use one fraction that you used today and represent that fraction in 3 different ways. So this one is an open-ended, low floor, high ceiling one where we want to see if they can represent each of these 3 models accurately before we move on to the next piece of the unit. If most of the class is having some trouble with one of the area models, we might want to do some continued work to continue practicing it until everybody is understanding the 3 different ways. Now back to our progressions rubric for assessment. The 3 models aren't necessarily a single box within here, but help us to build kids up in the progression. So if kids are still really set on the area model or really own this one, then put their name here, make sure that they're able to represent fractions using an area model and counting using an area model. If they're able to model fractions using a number line like this and understand what that means, then put their name, their number here. Now the next one moves a little bit more into the symbolic, and we'll continue to practice these, but if students can express improper and mixed fractions fluently back and forth, then we're going to put their name here. If you're not seeing evidence of this from this last lesson, that's okay. We're going to keep coming back to these learning opportunities. There's also this one where they compare and order fractions on a number line. And so if you're starting to see students using benchmarks to compare fractions like this, 1 4/7 is a little more than 1 1/2. So, and it's pretty close to 2. So doing that reasoning, you might be able from this one to say that some students are confidently able to do this work using that linear model, for example. Maybe some students need support, and maybe some students are not quite there yet. They're still working in expressing fractions in different ways, which is great. It gives you that data to know when to move forward. When your assessment data from this lesson shows that students are understanding the 3 different ways of representing fractions and able to compare and order fractions on a number line, then it's time to move on to the next section of this unit called Exploring Fractions and Mixed Numbers.